All right, today we're going to do lesson 11.5, which is multiplying and dividing rational expressions. Now, yesterday we went over what the word rational means. It's just any number that can be written as a fraction. So we went over, we're just basically multiplying and dividing fractions. Now, what we learned in yesterday's lesson in 11.4, you will have to carry over into today's lesson because I'm just simplifying now fractions that are being multiplied. Remember, yesterday, what we started off with is we said, if there is a variable that has a plus or a minus sign beside it, I have to put the pair in parentheses because those two terms cannot be separated. In order to cancel anything out, they've got to be identical. Now, what I can do with that pair in parentheses is take out a greatest common factor so that I can cancel something out. But other than that, unless it is identical to what's in parentheses, I cannot simplify. So guess what? Today, I have to follow that exact same rule. But this time, okay, I've got two different fractions instead of just one fraction. So I can simplify diagonal, all right? In this problem right here, this very first problem, do you see anything that I need to put any parentheses around to make a pair? No, there's not anything to put parentheses around because nothing is being added or subtracted. I see everything is right beside the variable. It's being multiplied. So let's simplify. Let's start with 5n squared times 10n to the third. Let's simplify the numbers, 10 and 5. What number can go into both 10 and 5? 5. 5 goes into 5 one time. 5 goes into 10 two times. Now let's simplify the variables. I have n squared and n to the third. So how many n's can I cancel out? 2. That takes away those two right there. And if I cancel out 2 from n to the third, how many am I left with? 1. So I write that n right there that I'm left with. Okay, now let's simplify 7n to the fifth and 14n. So 7 and 14, what number can go into both 7 and 14? 7. 7 goes into 7 one time. 7 goes into 14 two times. Now let's simplify my variables. I've got n to the fifth and n. So that means there's just one of them. So how many can I cancel out? 1. Very good. There's only 1 to cancel out down here. So that's the maximum I can cancel out. So if I cancel out 1 on the bottom, I'm going to cancel out 1 on the top, which leaves me with how many n's up top? 4. Very good. So now I just multiply straight across. 1 times 2 is 2. If I have 4 n's here and 1 n here, how many do I have left? 5. Over 1 times 2 is 2. I have no n's left on the bottom because I've canceled all of them out. So is this my final answer or is there something else I can simplify? I can cancel out the 2's because look, they're one on top of the other. And nothing is being added or subtracted, so there's nothing that's a pair that I can't cancel out. So I know if I have 2 over 2 and you leave an answer on the test that's 2 over 2, that's going to be wrong because what is 2 over 2? 1. Okay? So I can simplify this to 1 n to the fifth. Or you don't even have to write that 1 there. You can just cancel out the 2's and say, all right, I've just got n to the fifth. And that's my final answer there. Okay? So do you see how today's lesson is almost identical to yesterday's, only this time we're adding in another fraction. Okay? Let's do this next one. Now this next one is a little more in depth because I'm going to have to factor and take out the greatest common factor of some things. First of all, before I get started, I see that I'm going to need to go around and put parentheses over or on things. So what should I put parentheses around? Y minus 5. Very good. And 3y squared minus 3y. Now, before I do anything here, okay, I want to look and see, is there a greatest common factor I can take out or do I need to factor anything? First of all, y minus 5. Is there a greatest common factor? No, so that stays the same. But what about 3y squared minus 3y? Do I have a greatest common factor there? Yep, they both have a 3, so I could pull a 3 out. They both have a y, so I can pull y out. All right, once I do that, 3 divided by 3 is 1. If I had 2 y's and I take out 1, I'm left with 1. 3 divided by 3 is 1. If I had 1 y and I took it out, I'm left with 1. Or I'm sorry, I'm left with no y's. All right, so basically what I've done there, once I take out that greatest common factor, this denominator is replaced by this. That's my new denominator. So I like to go ahead and just cross it out so I don't have to rewrite the whole problem. I just write it underneath it, so therefore I see that that's my new denominator. Now, I'm going to need to do the exact same thing to this right here, because anytime you have a trinomial, what do they want you to do to it? Factor it. So, let's list the factors of 5, which are 1 times 5. Which ones are going to add together to give me 6? 1 and 5, obviously. They're my only choice. Okay? So, I'm going to put my 2 parentheses. I know I've got a y here and a y here, a 1 here and a 5 here. And what are my signs going to be? Minus, minus, because I know that this is a plus right here. So I know that my signs have either got to be plus, plus, or minus, minus. And I look to this sign right here to find out. If it's a minus, they're both going to be minus. So now I can cross out this denominator because I have replaced it with y minus 1 times y minus 5. That is my new denominator. Now I can look and say, all right, what can I cancel out? So I look diagonal. Let's look this diagonal first. What do you see that's identical that I can cancel out? Y minus 5. Very good. So I'm going to cancel out the y minus 5s. Now let's look identical this way. I'm sorry, diagonal this way. First of all, can I cancel anything with 1y minus y? I'm sorry, 1y minus 1. No. So that's off limits. So right now, all I'm looking at is 2y squared and 3y. Is there any number other than 1 that I can simplify 2 and 3 with? No. So I move on. I don't have anything to simplify the numbers. But what about y squared and y? Can I simplify that? Yes. I can take away that y there and take away 1 from here, and I'm left with 1. Okay? So everything's simplified diagonal for now. What am I left with up top that's going to become my new numerator? 2 and y. Very good. That's all I'm left with up top. Now, what I'm left with on the bottom? I'm left with this 3 right here. So that needs to be written first. Then I'm left with 1y minus 1. And I'm left with y minus 1. Now, you may say, okay, I'm looking. Is there anything else I can cancel now that I've got one fraction, one on top of the other? Okay, and you look at these right here and you say, oh, those are the exact same, so can I cancel them out? No, because they're side by side. In order to cancel out, they've got to be one on top of the other or diagonal when I still have my 2 fractions that are being multiplied. So this is my final answer because there's nothing else I can do to this problem. All right, let's do this last problem now. Now, this looks different because this last problem that I have multiplied has 2x minus 3. And I'm supposed to be multiplying and dividing rational numbers, which means I've got fractions, right? So the easiest thing for me to tell you to do is to write the number that is not in fraction form in a fraction, which all that means is I do what? Put it over 1. Very good. Now I can see, oh, okay, I can figure out what I need to do. What do you think I need to do first? What do you see that needs parentheses around what? 2x plus 1. Very good. That's a pair. It cannot be broken up. I do not want to be mistaken about that. Now, what else do you see that needs to happen? Factor. Very good. I cannot leave that just like it is. Now, this one, we're pulling back all the way from the last test. I've got to factor when I've got a number in front of x squared. So I've got to multiply a times c, which is 6. I'm going to write it up here so we can have enough room to work. 1 times 6 and 2 times 3. Which ones are going to subtract to give me 1? Since there's no number in front of this, I know there's a 1 there. I know that's going to be 2 and 3. What I've got to figure out, though, is because this is a minus sign right here, I know one of these are going to have to be a plus and one's going to have to be a minus. So I asked myself, okay, is the 2 going to be the plus or is the 2 going to be the minus? Well, let's look. Let's look at B's sign. If B is a negative, or whatever that sign is, that sign has to go to the largest term. So that means 3's got to be negative and 2's got to be positive. All right? So when I write this, now I'm going to write it over here to the side so we've got enough room. 2x squared plus 2x minus 3x minus 3. Don't forget, remember, this is how we have to do this. Now factor by grouping. Take out the greatest common factor, which is 2x, and I'm left with x plus 1. Take out the greatest common factor, which is negative 3, because that 3 is a negative right there. I know I have to take out a negative number, and I'm left with x plus 1. So my new denominator down here that is factored is going to be 2x minus 3 and x plus 1. So I can draw a line through that because that is no longer my denominator. My new denominator is 2x minus 3 and x plus 1. You see where I got that, right? I grouped those together. That became my first term, and this became my second. That's just a review. I'm going to erase all this so we've got room to work now. Okay, now it's time to cancel out. So what can I cancel out? I'm looking diagonal. Anything here that can be canceled out? Not there. Now what about here? What can be canceled out? The 2x minus 3 and the 2x minus 3 because it's identical. Okay? So now on top, I'm left with 2x plus 1. And on bottom, I'm left with x plus 1. Now I see that I have this 1 right here, and I could write it out in front, because remember, anytime you have a single number left, you always write it out in front. But I don't have to write that 1 there, because remember, a 1 doesn't ever change anything when I multiply or divide by a 1. So I don't have to write it. Now, can I cancel anything else out? No, because they're not identical. As close as they look, 2x plus 1, x plus 1. They look so similar that you want to say, oh, but I could cancel that out and I'm left with 2. That is not correct. Because they are a pair, it's already grouped together. There's nothing I can do to simplify this unless it is identical, and it is not. So that is my final answer. That's how you multiply two fractions or two rational expressions. You simplify diagonal, then get one fraction and see if you can simplify even further. Don't forget, you're probably going to need to do a greatest common factor at some point, and you're probably going to need to factor a trinomial at some point. Okay, let's do this last example now, which is division. Now, if you remember back at the very beginning of our math class, I'm talking probably the first 9 weeks of school, we learned how to divide fractions. Did we ever divide fractions? No, we did not. What did we do instead? Multiply by the reciprocal, or KFC. Keep, flip, and change the sign. Okay? So that's exactly what I'm going to do here. Nothing is going to be different. Okay? So I keep my first fraction, which is n minus 2, over 2n. I flip my second fraction, which is going to be n plus 5 over n minus 2. And I change my sign from division to multiplication. Now I need to go around and I need to put some parentheses. Parentheses need to go here, here, and here. What can I cancel out? N minus 2. So I'm left with n plus 5 over 2n. Is there anything else I can cancel out? Nope. This is my final answer. All right, let's do this last problem. Again, I see it's division. Do I ever divide by fractions? No. What do I do instead? Keep, flip, and change. So, but look at this last one. X minus 4 is not a fraction. So what do you think I should do to it? Put it over 1. Very good. That's going to make it a whole lot easier when I flip and change it. So I've got 5x squared minus 20x over x plus 5 times 1 over x minus 4. All right, I need to go around and put some parentheses. So parentheses needs to go here and here because they both have the plus sign or minus sign by them. Now, what do you see that I can do? Greatest common factor. Very good. Look right here. 5 and 20, x and x. I know I've got a greatest common factor there. What is the greatest common factor of 5 and 20? 5. Since they both have an x, this one has x squared and this one has x. So how many can I take out? 1. So now I just divide. 5 divided by 5 is 1. If I had 2 x's and I took 1 out, I'm left with 1. 20 divided by 5 is 4. If I have 1 x and I took it out, I'm left with none. So I can cross this out because that's no longer my numerator. 5x times x minus 4 is my numerator. What can I cancel out now? But you say, but it's not identical because this one does not have a 1 in front of it. Anytime I have a variable without a number in front of it, what's the number in front of it? An understood 1. Exactly. So yes, it is actually the exact same thing. So now I'm left with 5x over x plus 5. Is there any way to cancel out the 5's and the x's? No, because x plus 5 is in parentheses, and there is nothing else I can do to simplify. So this is my final answer. Okay? So that's how you simplify by multiplication and division of rational numbers. Remember, what we learned yesterday has to be applied to today's lesson, and what we learned today is going to be applied to tomorrow's lesson. So we're building a concept here.